In this video, we shall discuss on the characteristic function of the binomial distribution. We are to find the expectation and the variance for the characteristic function of binomial distribution. But first, we will have to write the characteristic function for the binomial distribution. For more on this topic, you need to subscribe to this channel. The characteristic function for the binomial distribution is written as q plus p exponential it raised to the power of n. So, we are first to look for the expectation of the binomial distribution. So, to obtain the expected value of x, we have to find the first differential for the characteristic function of the binomial distribution. So, for we to find the derivative of the binomial distribution, that means the first derivative, we get n into q plus p exponential it raised to the power of n minus 1 multiplied by, we also differentiate what is inside from function of a function. So we have p I, the characteristic function, exponential it. So we have succeeded in differentiating this. The next thing to do is to rearrange this very well. So rearranging it, we have that this is equal to n p I into q plus p exponential it raised to the power of n minus 1 multiplied by, since we have moved this over to this side, so we have exponential it. So we write at t is equal to 0. At t is equal to 0, that means anywhere we see t, we put 0. We will now write this over to this other side. So we have the characteristic function at t equal to 0. It means anywhere we see t, we put 0. So we'll write it as n p I into q plus p exponential. So this comes to 0 n minus 1 multiplied by exponential I 0. We should also note that from indices, we have that exponential I 0 is the same thing as exponential 0. And anything raised to the power of 0 is 1. So we have 1 here. It means anywhere we see exponential I 0, we put 1. So we have that our characteristic function at t is equal to 0 is equal to npi into q plus p. This comes to 1, so we have n minus 1 multiplied by 1. So it then means that our characteristic function for the first derivative is equal to npi into q plus p raised to the power of n minus 1. And we note that from probability, the probability of success plus failure is equal to 1. So the whole of this becomes 1. So our characteristic function at t is equal to 0 will now be npi, because the whole of this has turned to 1. For more on this topic, you need to subscribe to this channel. Also, it then means that our expected value of x is equal to negative I characteristic function at t is equal to 0 is equal to what we have here. So we now write it as negative I multiplied by npi. which is the same thing as negative I squared multiplied by npi. We should note that from the characteristics function, I squared is equal to, so we have negative I squared multiplied by np. I squared is equal to 1 from the characteristics function. So we can now write our expected value of x. To write our expected value of x, we move over to this side. So our expected value of x is equal to, since I squared is equal to 1, we now do this. It means that we have negative 1 and p. Therefore, our expected value of x is equal to np. So we have np as our expected value of x. But before we find the variance, we have to look for the expected value of x squared. So we write to obtain the expected value of x squared. What do we need to do? We need to take the second derivative of what we got before. The second derivative, that means we need to find the second derivative of our characteristics function. Now, for we to find this, there is something we need to do. We need to recall what we have first in our first derivative. In our first derivative, we have something like this. So we move over to this side to write what we got in our first derivative. In our first derivative, we got so we write, recall that in our first derivative, when we differentiated, we got q plus p p I t raised to the power of n minus 1 multiplied by p I p exponential I t. That means I multiplied by exponential I t. So this is what we got when we had our first derivative. Now, to obtain this, we use what is called the product rule of differentiation. That is, to obtain our second derivative. If you watch that, you see that we have a function here, which is our first function. We have another function here. So this is u and this is v. All we need right is u, the v all over the t, plus v, the u all over the t. For more on this topic, you need to subscribe to this channel. So the whole of this function is our u. So we write it as, our u becomes, we bring it as u into q plus p exponential it raised to the power of n minus 1, the v all over the t. That means we differentiate this, we get p I. Of course, the characteristic function will come again to make this I squared. Then we have exponential IT plus our v, we bring down our v, p I exponential it multiplied by du all over the t. That means to differentiate this, du all over the t. We can write it here to give us n multiplied by n minus 1 into q plus p exponential it raised to the power of n minus 1. As we are differentiating this, we also differentiate the function inside, which is multiplied by p, then we have I exponential it. That means the characteristic function. So we have succeeded in differentiating this the second time. All we need do is to put t equal to 0. So if we make t equal to 0, it means this function will turn to 1. So we have that at t is equal to 0. That means anywhere we see t, we put 0. So we have our second derivative of the characteristic function will give us, sorry, this is n, will give us n into q plus p. The whole of this will turn to 1. So we have at t is equal to 0, exponential 0 is equal to 1. So we have this raised to the power of n minus 1 multiplied by p I squared. So this is what we have. This will go because it turns to 1 plus the whole of this turns to 1. We have pi. Now we have the whole of this, which is multiplied by n into n minus 1 into q plus p raised to the power of n, sorry, this turns to n minus 2 multiplied by, this will turn to 1 pi. So this is what we got. It then means that our characteristic function for the second derivative is equal to, we bring this here to give us n pi squared into q plus p raised to the power of n minus 1. The whole of this has come here plus this. P multiplied by p is p squared. I multiplied by I is I squared. So we have p squared I squared multiplied by this n into n minus 1 q plus p raised to the power of n minus 2. So this is what we get. Of course, we know from probability that q plus p is equal to 1. It then means that anywhere we see q plus p, we remove it and multiply the function next to it by 1. So we move over to this other side. We should remember that our expected value of x is np, because we recall it when we are looking for the variance. So you have to delete the whole of this. For more on this topic, you need to subscribe to this channel. So we can now write our characteristics function for the second derivative. Okay, this is 0 and this is 0, sorry. So we have that our characteristics function at t is equal to 0, the whole of this turns to 1. So we have npi plus p squared I squared, p squared I squared into multiplied by n into n minus 1, and the whole of this turns to 1. So we have that npi squared plus n into n minus 1 p squared I, which is our characteristic function at t is equal to 0. That means the second derivative. If you watch out, we have I squared here and we have I squared here. So we bring out I squared to give us np plus n multiplied by n minus 1 p squared. So this is at t is equal to 0. So to write our expected value of x squared, our expected value of x squared is equal to I squared negative I squared, our characteristic function at t is equal to 0 is equal to this. So we now write it as negative I squared because of this sign here into np plus n into n minus 1 p squared. Of course, this will give us negative 1 into negative 1 multiplied by np plus n into n minus 1 p squared. So this becomes our expected value of x. But we are not done yet because negative 1 multiplied by negative 1 will vanish the whole of this. So we'll write our expected value of x squared to be this. And we'll write it here. So we move over to this side. For more on this topic, you need to subscribe to this channel. So it then means that our expected value of x squared will be equal to the whole of this, which is np plus n into n minus 1 then p squared. So this is what we get. This is what we get as our expected value of x. The next thing to do is to find the variance. So we have succeeded in finding the expected value of x squared. We have also succeeded in finding the expected value of x. If you recall, we note that the expected value of x, like we got before, is np. So we cannot find the variance if we have gotten this. This is because the variance of x